Let's take a look at some fuses. We'll go over some terms first. So overload is the excessive current in a circuit path without insulation breakdown. Now short circuit is current flowing through abnormal paths, and interrupter rating, or the AIC, is a current that a fuse will be able to interrupt without being destroyed. Okay. So the NEC National Electric Code here in North America requires that overcurrent protective devices be connected to each ungrounded conductor on the line side, and a circuit can only be loaded to 80% of its full load rating. In other words, if you have a number 12 wire, which is good for 20 amps, and you fuse it with a 20 amp fuse or a breaker, and it was at 120 volts, you would think that you could have 2,400 watts on that circuit, but they limit it to 80%, so you can only load it up to 1,800 watts. Okay. Now, the motor should be fused with a time delay fuse rated at 175% of the motor's full load amps, or a non-time delay fuse at 250%. Okay. Now, motors have overload protection in them. Overload heaters in there are magnetic ones, and thermal or magnetic, and so it protects against overloads, and the fuses are protecting against a short circuit. Okay. Now, branch circuits, when you calculate the size of branch circuit you need, you have to add up all the non-continuous loads plus 125% of the continuous loads to do your calculations for a circuit. Okay. Now we'll take a look at semiconductor fuses. Now I'll put this on my. I'll put a link to this, my notes here. They have this symbol here. I don't know if you can see it on there, and but they're there to protect diodes and SCRs and triacs and your electronic equipment. They're ultra rapid fuses, and they come in three classes: AR, GR, and GS. Okay, so AR is a short circuit protection for semiconductors. GR is overload and short circuit protection for semiconductors, and GS is overload and short circuit protection for semiconductors and cables and switchgear. Okay, so applications for those are power rectifiers, UPS, converters, motor drives, a soft start or a variable speed drive, and solid state relays. Okay. Now, PV fuses, those are for solar, and here's a symbol here. Those are for solar panels. Okay, and those are designed to protection for photovoltaic systems. So the application for those is inverters, combiner boxes, battery charge controllers. So they're designed for the solar industry. Okay. Now you always come across this I squared T, which is amperes squared seconds, and that's just the melting point of a fuse. Okay. So the higher the melting point, the longer the fuse will take to open. Okay. So when you're rating the fuses for your semiconductors and that, you take a look at your spreadsheet or your data sheet for your semiconductor, and it'll give you a I squared T rating for that semiconductor, and you should rate the fuse to be less than that rating there. So the fuse will open before your semiconductor device breaks or burns up. Now, fuses are marked with the speed rating on them. Okay, how fast they're going to open up. So FF is very fast, F is fast acting, M is medium, and T is slow acting or time delay, and TT is very slow acting. Okay, so now industrial fuses, those are cartridge fuses. Industrial fuses are marked with these, like we talked before, with the AG, GR, GS, and then a GG, which is fast acting overload for general applications, and an AM, which is slow acting circuit for motors, and a GM for those are short circuit and overload protection for motors too. So you'll find those ratings on there. Okay, so these fuses here, these are 600 volt fuses, and these are time delay fuses for motor starting. This one has a window there so you can see if it's actually tripped or not. These fuses here are these aren't time delay fuses, but they're for motors, and they're for 250 volts. Okay. Now these two happen to be 600 volts, and this is a class J, this is a class K, and this one here is good for a AIC rating of 100,000 amps. Okay, huge. And then these here are this is a time delay fuse for motor starting. This is 240 volt for 240 volt motors. Okay. Now these here are actually 600 volt fuses, and these are class CC volt fuses, and they come in all different all different varieties, and every manufacturer has a different name on there and label on there. This is ATQ, this one's KLDR, FNQ, LPCC, this class CC fuse, and then these two are they're not time delay, KLK, and a KCL fuse. Okay. Now they have these little knobs on the bottom because the 600 volt fuse holders they go into have rejection clips on them, so you can't put one of these fuses in this clip over here. Same with these have rejection clips on them. So these here are this one's a time delay fuse, and then these are normal fuses here, and they're for 240 volt. Okay, 250 volts there. Now down here, this is a and L fuse, and these are car audio fuses, but this one's a 300 amp, so these are good for using your car low voltage ignition wires and that. And this is the same thing, but it's in a miniature one. Now these are the typical fuses you'll find in your car, which it's an ATC/ATO. Okay, and they're 12 volt fuses, and these here are the they're ATM, which is a miniature size of one of those. Okay, now these glass fuses are AGU fuses, and they're I think they're good for 32 volts or so. And now we'll take a look at the these are photovoltaic fuses here. This has some. Now, I don't know if you can see the symbol on there or not, but it has a fuse, and then it has a symbol for a solar panel on there. Okay. And this one here is a GPV, and it's for a solar panel. That's a 20 amp, and it says solar PV on there. And these are 1,000 volt fuses. Okay. So these are 32 volt, these are 1,000 volts, these are 600 volt, and these are 250 volt fuses. Now this one here is a GR fuse. Okay, so that GR is fast acting, but it's for general applications. Okay, and this one here is the same thing. Okay, those are 2 amp fuses. This one here happens to be a labeled as an FF, very fast acting fuse, and it's good for 1,000 volts too. So it's a 1,000 volt fuse. These are 1,000 volt fuses, 600 volt fuses, and then this is a fuse holder for a solar panel. It fits right into connection in line with it, and you can see on there these are 1,000 volt fuses also. Okay, and this one here is a fuse for this goes into a VFD drive on a motor, and you can see the semiconductor fuse in there. It has a little diode. There's no diode in here. It's just telling you that it's good for a semiconductor, and it's the AR, so it's a short circuit protection. Okay, these are expensive fuses. They're about $170. All these things. These are $30. Fuses aren't cheap, but that's kind of just a quick look at some fuses, and it's you have to kind of study which fuse to put in what application. Check with your manufacturer, and check with your local codes what you can actually use to fuse things for safety. Anyway, thank you.